So we move forward to the next talk in the series of Indian knowledge system. For the next talk, we have the title as Eclipses in Indian Inscription, and it will be delivered by Dr. Padmaja Venugopal. She is a ma'am. Are you there?
Yes, sir, she is here.
Yes.
Yeah. So I will just give a introduction to the speaker. Professor Dr. Padmaja Venugopal is the head of department in SBJ Institute of Technology, Bangalore, and she has teaching experience of more than 26 years and research experience of 23 years. And she has participated, she has published in a lot of reputed journals and also participated in lot of conferences and has been invited as a resource persons in many of the acclaimed national and international conferences. And she has also undertaken a research project, a 3-year research project titled Comparative Study of Planetary Models in Respect of Classical Indian Astronomy vis-a-vis Platonic and Copernican Models during 2005 and 2008, sponsored by INSA, New Delhi. So, and the project has been completed. So, we have a very good speaker with us for presenting us regarding eclipses in Indian inscription. So, Professor Venugopal, please, you can start your presentation.
So my talk will be basically on eclipses, inscriptional and literary evidences in astronomy. My talk will be more of a generic in nature. I will not be touching upon the technical details. As Professor Mahesh Shetty has already spoken of the method of computation of eclipses, mine will be more general thing. Now, since these eclipses are known from the time long since there are references to eclipses in the Rig Veda itself. So I will be referring to the references since Rig Veda. So before I go to give the references, we shall briefly get to know the cause of the eclipses. As most of us know, the solar eclipse will happen on a new moon day and the lunar eclipse on a full moon day. But every month we will get the new moon and the full moon. One may wonder why every new moon day we don't have a solar eclipse, and every full moon day why don't we have a lunar eclipse. That is because of the different paths traced by the sun and the moon. The sun takes an apparent path around the earth, and moon being the satellite of the earth, it has another path which we call it as moon's orbit. The sun's orbit and moon's orbit, they are inclined at an angle about 5 degrees, and the sun's orbit and the moon's orbit, sun's orbit is referred to as ecliptic. They cut each other at 2 geometrical points which are referred to as the ascending node and descending node in modern terminology, and Rahu and Ketu in Indian parlance. So if the moon is close to one of the nodes on a new moon day or a full moon day, the eclipse will happen, and this is the geometry of a total lunar eclipse. On a full moon day, if the sun and the moon lie on either side of the earth, the sun's light, if it falls on the earth, it creates a shadow cone. So if the moon is completely into the shadow cone, we will have a total eclipse. As you see in the figure, this cone BVD, that is called the umbral region, and LBV and VDN, these two are the penumbral region. Now in Indian system, penumbral eclipses are not taken into account. When the moon enters the umbral region, if it is totally into the umbral region, we have the total eclipse, and if partially moon is entering the umbral region, we have a partial eclipse. In the case of the solar eclipse, we have one more type, namely annular eclipse or Valaya Grahana or Kankana Grahana. That is, the sun's angular diameter will be slightly greater than that of the moon's angular diameter. Moon will be covering the sun, leaving a small ring, outer ring, which will look like a diamond ring, hence the name Valaya Grahana or the Kankana Grahana. This is possible only with the solar eclipse. Now, if you look at the geometry, I will not be going into the details of it. So, during a total lunar eclipse, the bigger circle is a cross section of the shadow cone. When the moon enters a shadow cone, we have the eclipse happening. So, for a total eclipse, we need to go for registering 5 circumstances. When the moon is at the position x1, the eclipse is said to have begun. x2 is the position of the moon where the totality begins, and O is the middle of the eclipse. When the moon is at x3, then the totality is supposed to have ended, and x4 is the end of the eclipse. So, when there is a total eclipse, we need to go for recording 5 circumstances. In the case of a partial eclipse, we have only 3 circumstances recorded, namely the beginning of the eclipse, middle of the eclipse, and the end of the eclipse. And to calculate the half duration of the eclipse, we have an expression here. However, I will not go into the details of all these. As mentioned by my earlier 2 speakers, Professor Balchandra was telling about the system, that is, computer programming we have developed in Bangalore. Our team has gone for using what is called improved Siddhantic procedure, which is a computer program developed by Dr. S. Balchandra, and we had been retaining the framework given by our Indian system. We have gone for contributing improvements as per the formula available, as per the modern formulae available. Now I will go to the references we have in the Rig Veda. Professor P.C. Sengupta refers to the eclipse which is mentioned in Rig Veda as a central solar eclipse. The phrase a central solar eclipse means the center of the sun, moon and the observer are in line. So this was observed in Rig Veda. So for the eclipse to be a total, this is a solar eclipse referred by P.C. Sengupta. For the total solar eclipse, the sun and the moon should be on the same side of the earth. In other words, the longitudes of the sun and the moon should be equal. Now, this eclipse is said to have been observed in Kurukshetra, which is of latitude and longitude given here, and instant of new moon is one of the parameters we very much require, and this is referred to as Ketu Grasta Grahana. Now, the moon is close to the node Ketu, and hence this eclipse is referred to as Ketu Grasta Grahana. And we have the 5 circumstances recorded here: beginning, end, beginning of the eclipse, beginning of totality, middle of the eclipse, end of totality, end of the eclipse, and half duration of the eclipse is recorded as 2 hours 53 minutes. Now, if the eclipse is total, the ratio or the grasa, which we call it as in Indian terminology, or the magnitude of the eclipse in the modern parlance, should be greater than 1 for the eclipse to be total. If the eclipse is partial, the ratio to the obscured body divided by the moon's diameter, angular diameter, will be less than 1. If it is less than 1, the ratio of it is less than 1, the eclipse is referred to as partial, and if it is a total eclipse, then angular, that is, the magnitude of the eclipse will be greater than 1. In the case of annular eclipse, the ratio will be close to 0.9 something, and this is the artistical imagination of the that is solar eclipse in Rig Veda. Since we had no telescopes then, based on the artistic imagination, we have the solar eclipse that could have been observed during the period of Rig Veda. Now, we have one more example. I'll be referring to the eclipses that are mentioned. We have the eclipses that are mentioned in inscriptions as well as in the records given in various periods. Now I take up the example of Buddha's Nirvana period. This is another example given by P.C. Sengupta, and this eclipse is annular, and we have the instances of new moon recorded, true longitude of the sun and the moon. See here, Nirayana means Nirayana longitude, and this is a practice done in Indian system. So the calculations of the longitude of the sun and the moon were made with reference to group of stars, which is referred to as Nirayana system. In modern system, we are going for the calculation with a reference to the tropical system. Now moon's latitude, we find it as 5 minutes 58 minutes 2 seconds, and this is the longitude of Rahu, 290 degrees 17 minutes 34 seconds. So if we look at the longitude of the moon and longitude of Rahu, and if you go for taking the difference, the moon's latitude is close to the moon is close to the node Rahu, and this is an annular eclipse where we find the magnitude coming out as 0.9. And we have another solar eclipse which is recorded in the year 2451 BC. This is again a reference given by P.C. Sengupta. Now here, this is an example of a solar eclipse. This is a total solar eclipse. I will not go into the details of the technical details of the eclipse. Since this eclipse turns out to be a total one, we have the magnitude of the eclipse as 1 point something. And now we have a very interesting astronomer, Hemangada Thakura, who has composed Grahana Mala, means garland of eclipses. He was a petty king in the period of Akbar the Great. During his imprisonment, he had gone for composing this text. He has recorded 1432 eclipses during his imprisonment. He has given examples from the year 1620 to 2708 CE. Now this is a folio from Grahana Mala. Just to give a feel of it, I have gone for displaying this. Now each verse will contain the following details. So he has given the record of eclipse in a verse. So each verse, that is 2 lines if you take, it contains so many details. That is Shalivana Shaka, then Ahargana or Divrunda, that is number of days elapsed since the beginning of that solar year. Then we have the information of full moon and whether it is a full moon or a new moon, depending upon it is a lunar eclipse or a solar eclipse. Then there is a mention of the nakshatra from the eclipse day. Then the name of yoga is mentioned. Also there is a reference to the weekday, number of elapsed days since the corresponding solar month. Then we have the name of the lunar month and the half duration of the eclipse. Then beginning of the eclipse, which is referred to as Sparshakala, end of the eclipse, that is Mokshakala, and also the moon's latitude, whether it is in the south or north. That is, if the moon's latitude is north, we take it as positive. If it is south, it is taken as negative. And these are some of the examples we have taken from Hemangada Thakura's Grahana Mala. Now, since the eclipse dates here started from 1620 as a sample, we have taken the dates in 1620 and we have worked out the details using our computational procedure. Also the later examples from 2009, recent examples 2009, 2017 and 2018. These are the dates given by Hemangada Thakura, and possibly the author has gone for recording the eclipses that were visible in India. So we have gone for verifying the beginning of the eclipse, whether it was a full moon or a new moon. So the first example is 1620, June 15th, Monday. Incidentally, Vishwanatha, the commentator of Grahalagavam, also belongs to the year 1620, and he has worked out examples of the period 1620 using Grahalagava method, that is Ganesha Daivagya, who has composed Grahalagava. And as already mentioned by our Professor Dr. Balchandra Rao, that method given by Grahalagavam or the Ganesha Daivagya, he has dispensed with the trigonometric ratios, and that method was very much adaptable and a simple method by the Panchanga makers. So here, lunar eclipse, if you look at, it falls on a full moon day, and the timings recorded 6 hours 15 minutes. We calculated it and we verified it with the timings given by Hemangata Thakura, and also we have the beginning and end of the eclipse for that particular day as 5 hours 26 minutes, and the end of the eclipse is recorded as 8 hours 12 minutes. Magnitude is greater than 1, so turns out to be a turns out to be a total eclipse. Then we have one more lunar eclipse in the year 1620 December, and the details are there. We verified it with the values given by Hemangata Thakura, and we found that all the values tallied very much well with whatever he had given. And this is an example, that this is a pictorial representation of one of the eclipses, which is taken as an example from Hemangata Thakura's Grahana Mala. He has recorded August 7, 2017 as a partial lunar eclipse. Since the eclipse is partial, we can go for recording only 3 circumstances, namely the beginning, middle and the end. And we have a mention of Saros here. Whenever we talk of an eclipse, you can find the mention of Saros. This particular eclipse, the eclipse which I had shown, belongs to the Saros. I don't find the number here. Every eclipse, whichever we witness, will be belonging to a Saros. Saros is a cycle. I think this would have been explained by Professor Mahesh Shetty in his yesterday's talk. It is a cycle of 18 years, 11 days and 8 hours. So the eclipse is supposed to have getting repeated once in 18 years, 11 days and 8 hours. And here we have one more example of annular solar eclipse. This example is considered from Epigraphia Karnataka. Since we belong to Karnataka, I thought it will be precise for me to go for examples from Karnataka. This eclipse was witnessed in Soruba, and this eclipse belonged to Saras number 94. Since this is an annular eclipse, annular solar eclipse, and the new moon is at 13 hours 40 minutes, longitudes of the sun and the moon are equal, and we observe that moon's latitude is very small and it is close to Rahu. So this is Rahu Grasta Grahana. So this is the summary of the eclipse, because it is a total. This is annular eclipse. As I had mentioned earlier, the magnitude of the eclipse will be close to 1. The ratio of the obscured body divided by angular diameter of the moon is very close to 1. So the moon's angular diameter is slightly smaller than that of the sun's angular diameter. So we have a ring of light which will resemble to a diamond ring, and this was also witnessed. Diamond ring was also witnessed in the year 1994 in Diamond Harbour, and it was telecasted over the TV, and there was a huge discussion about that also. And this is a pictorial representation of annular solar eclipse that had happened in the 10th century, that is 938 February 3rd. Now this red mark shows the path traced by the solar eclipse. The places which lie on this red belt, they have experienced the annular solar eclipse. Here again we can notice the mention of the Saros number 94, and we have a very interesting date, 1148 April 20, and this date was considered by us from Epigraphia Karnataka University, and this is this is an example of a solar eclipse. On this very same date, we had more than 2 or 3 phenomena happened, and this was found by us when we went for calculating. We found that Mercury's position was close to the sun. In the coming slides, I'll be showing you all this. This is a record we had taken from Epigraphia, Carnatic University, and this is an example of a total solar eclipse. Now, we have this, we had found out, in fact, this was not found in that Epigraphia, Carnatic University. We found that the moon's position was close to that of Mercury. So we thought there could be a possibility of lunar occultation, and when we tried out, we found that there was a lunar occultation, and during the lunar occultation, the Mercury was retrograde. And this is another phenomena which we incidentally found out for the same date, that is 1148. Vatipata is the phenomena where the declination of the sun and the moon will be equal. On the very same date, that is 1148, we found that the sun's declination and moon's declination were more or less the same at 9 hours. So we concluded that Vatipata occurred on that particular day at around 9 hours 30 minutes, because around 9 hours 30 minutes declination of the moon also go rise to. So it was almost equal at 9 hours 30 minutes. Also 3 days later to 1148, that is April 20, we had experienced the eclipse. 3 days later, we found that there was a Mercury transit. So most of you would have witnessed the last Venus transit of this century, that is in the year 2012 in the month of June. So the next Venus transit would be witnessed in the next century, that is only after 105.5 years later. Venus transit is not a very frequently happening phenomena. There is a particular cycle. So Mercury and Venus has the probability of this transit, because the orbit of Mercury and orbit of Venus is inside the orbit of Earth. That is, orbit of Mercury and orbit of Venus, they lie in between the Sun and the Earth's orbit. So transits are possible only for the inferior or the interior planets, Mercury and transit. So we found incidentally that there was a Mercury transit, and these mentions of Mercury transit was not there in the Epigraphia Karnataka University. These are the ones, these phenomena we had calculated by looking at the positions of Mercury's sun. So in the case of Mercury transit, the procedure is similar to that of the solar eclipse. Participating bodies are the sun and the Mercury. We being observers from the earth, we can have a spectacular visual of this Mercury transit. So this circumstance is similar to that of the solar eclipse. Here, instead of calling it as beginning of the eclipse, we call it as beginning of external ingress, then beginning of internal ingress. This is similar to beginning of totality. Then we record the middle of the transit, then end of the internal egress, then end of the internal egress. Now we have one more example of a solar eclipse, which is an inscriptional evidence. Now this record of the eclipse was found at Ramalingeshwara temple, Sindhavala, Bellary Taluk. Since we being Kannadigas, we were very much fascinated by looking at this example, and we were tempted to calculate the eclipse and the circumstances of it. And this is a reference from EKU, volume number 1. So when we went to go for calculating the details of the eclipse, this turned out to be annular solar eclipse, and here we can find the magnitude of the eclipse very close to 1. And this is another example we have taken, that is, this is a solar eclipse on 11:30 October 4, and this red belt shows the eclipse, solar eclipse, annular solar eclipse that was visible along this belt. The places along this belt had experienced the annular solar eclipse, and this belongs to the Saros cycle number 110. And one more example from Sogal, that is, this is another annular solar eclipse we've taken from this was witnessed at Sogal, Belagav, Karnataka. This is an annular solar eclipse. I will not go to the details here. The details are similar to that of the other eclipses which we have earlier discussed. Now, this is an example from Kalidasa's magnum opus, Abhignana Shakuntalam. Earlier speaker, my friend Dr. Rupa had made a mention about the occultation, lunar occultation of this. So Kalidasa, apart from being a poet, is also probably an astronomer. He had given the reference of the lunar eclipse as well as the occultation, not the occultation, conjunction of Rohini with the moon. So we just went for verifying this date, and we just found that this happened to be a lunar eclipse. That is on 8th November 542 CE. We found that this is a total lunar eclipse, and this eclipse belonged to Saros number 83. So 5 instances are recorded here, and this is the verse we find in Shakuntalam, which reads as, "O dear Shakuntala, you are standing before me, who am now rid of the illusion of forgetfulness. O lady with a beautiful face, at the end of lunar eclipse, Rohini approaches to co-join with the moon." And now, after that is, this verse states that like the moon, like the star joining the moon, Shakuntala, Dushyanta, after coming out of his forgetfulness, could identify Shakuntala, and they rejoined. And this is the example that given in Abhignana Shakuntala. It is a lunar conjunction of Rohini with the lunar conjunction of Rohini, that is conjunction of Rohini with the moon. Now this is another example of solar eclipse, which was in the 15th century. 1520 AD is a epochal date of Ganesha Daivagya, who had composed is Grahalagvam, which is a very popular text. Now this is a pictorial representation. This date I had taken it from R.C. Gupta's paper, and this was found in Guru Nanak's. That is where Guru Nanak was on his tour to various places. It is believed that he had stayed in one particular place on that particular day. He and his team had observed the solar eclipse, and this is an imaginary picture of the artist. Now about Bhaskara II, all of us have already heard from Professor Dr. Balchandra Rao. Bhaskara II is a very famous astronomer, and 900 years of Bhaskara was celebrated in the year 2014, and many programs related to Bhaskara and his works were conducted in various educational institutions, and we were also a part of some of the programs, particularly in Pune. Now we have taken a few examples from Bhaskara's period. The first one is 1620 AD. This is probably an example given by Vishwanatha, and the rest of the examples, June 7, 1183, November 17, 1183, and 1167, September 30. These are all examples which are close to Bhaskara's period. So we had tested all these dates using the computer program developed by us, and it all turned out to be lunar or solar eclipses as claimed by Bhaskara II. And the last column, we have the half duration of the eclipse recorded.
ಅಲ್ಲ ಇಷ್ಟು ಟೈಮ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ.
ಅದು ಬೇಗನೆ ಆಗೋಯ್ತು ಸರ್.
So
yeah, we thank Professor Venugopal for this talk on inscription of solar eclipse. So if anybody have any questions regarding the presentation, regarding the details which were given. Yeah. Either you can unmute and ask directly, or you can put it in the chat box. Anybody? Any question?
Screen okay. Okay, so come back to this. I'm sharing it from Keynote.
So are there any questions anybody would like to ask? Okay, so if there are no questions, of course you can always send questions to her, which in her email address, which will be shared in the group, and of course you can ask questions. They are also in the group, they can answer there. So I would like to thank again Dr. Padmaja, Professor Dr. Padmaja Venugopal, to have come to our platform and given a talk enlightening us about the Indian astronomical contributions by our astronomers, and how they have recorded it in details in various inscriptions, and through which we come to know about the that they were also keen observers. So with that, we conclude this part of the session on Indian knowledge system, and we break for lunch, because the next talk is at 1:30, that is 13:30, and after that talk will be on variable stars, star clusters and binary stars, and after that we will have the last session from 3:30 to 5 o'clock, where we will have the feedback and the questions.
Shailaja BS Nabantara.
Yeah.
She is also listening to you.